Alright, the next thing we're going to talk about is oxidation and reduction reactions. I didn't have time to get to this last year, so my students will not be quite as familiar with it. I know Miss Jones didn't get to it. I'm not sure if Cheek got to it. But we're going to talk about oxidation and reduction reactions, okay? You should know that in chemistry we're concerned mostly about the electrons, because when electrons are gained or lost, or if they're shared, then we have chemistry. I mean, that's what chemistry is all about, looking at the bonds and how things move around, how things rearrange, and it's all about how the electrons react that give us, our charge and our attraction and all such as that. Now, we're going to talk about oxidation and reduction reactions, and this is when an electron is either gained or lost. Okay, and oxidation occurs when an atom loses an electron. And oxidation occurs when an atom loses an electron. A reduction occurs when an atom gains an electron. A reduction reaction occurs when an atom gains electrons. Now, one cannot occur without the other. When something is oxidized, something else must be reduced. Or when something is reduced, something else must have been oxidized in order to account for that electron transfer. Now, what's an easy way to remember which one's reduced, which one's oxidized, who gains what, who loses what? Well, Leo says Ger. Leo the lion says Ger. Leo the lion says Ger. G-E-R. So Leo loses electron, means oxidized, loses electron, oxidized. Says Ger gains electrons, reduced. G-E-R, gains electrons, reduced. So Leo says Ger, loses electrons, oxidized, gained electrons, reduced. Just a simple way to remember that. Now, in order to understand whether or not an oxidation a reduction oxidation reaction has occurred, or a redox reaction has occurred, we must assign oxidation numbers. And assigning oxidation numbers is very similar to assigning charge, with a few modifications with that. And I have a few rules that are going to help you assign oxidation numbers. The first rule is elements in their elemental form, meaning that they are by themselves, they aren't bonded to anything, they're just by themselves in a reaction, have an oxidation number of 0. The oxidation number of a monatomic ion is the same as its charge. So if you have an ion sitting in a net ionic equation, its oxidation number is going to be equal to that of its charge. Nonmetals tend to have negative oxidation numbers, although some can have positive oxidation numbers in certain compounds or ions. Particularly looking at polyatomic ions. Polyatomic ions can kind of make your oxidation numbers a little bit funny. Oxygen always has an oxidation state of -2, or an oxidation number of -2, except when it is acting as a peroxide. You should remember that peroxide is a polyatomic ion. If it's acting as a peroxide, then its oxidation number is -1. Hydrogen has an oxidation number of -1 when it's bound to a metal, or +1 when it's bound to a non-metal. Fluorine always, every single day, has an oxidation number of -1, as does most halogens, with a few exceptions. A halogen most of the time is going to be a -1, but sometimes it can have a positive oxidation number when it's bonded with an oxyanion, or when it's looking at a polyatomic ion. Okay, a polyatomic ion. Polyatomic ions make things a little bit funny. The sum of the oxidation numbers in a neutral compound is 0. The sum of the oxidation numbers in a polyatomic ion is the charge of that ion. For example, if we're working with a compound like NaCl, that's a neutral compound. But if we're working with phosphate, PO4 3-, it's going to be -3 would be your charge on the ion. Right? So this is how to assign oxidation numbers to nonmetals. Now, metals are a little bit different. We have to look at the nonmetals in order to assign oxidation numbers to the metals. Why? Well, it's because of the transition metals have the different oxidation states. They can have various charges. Remember, we've talked about that. Those charges associated with the oxidation states, and particularly d orbitals, which we're going to talk about soon. Now, metals can have a charge from +1 to +7 depending upon the anion that they are bonded to. So we're going to practice this over in class, but you just need to make sure that you have these oxidation numbers rules memorized.